In this video, we're going to look at quadratic sequences questions. So the first question asks us to write down the next two terms in the following quadratic sequences: 4, 9, 17 and 28, and -2, -5, -10 and -17. And question 2 asks us to work out the nth term expression for the following quadratic sequences: 5, 8, 15 and 26, and -3, -7, -16 and -30. Okay, so let's make a start by answering question 1, part A. We've been asked to find the next two terms in the quadratic sequence 4, 9, 17 and 28. Well, a quadratic sequence is one where the difference between successive terms either increases or decreases by the same amount. So for the given sequence, 4, 9, 17 and 28, the difference between 4 and 9 is 5, between 9 and 17 is 8, and between 17 and 28 is equal to 11. And the sequence of numbers that this produces is called the first difference. Now if we do this again, the difference between 5 and 8 is equal to 3, and the difference between 8 and 11 is also equal to 3. And this new sequence of numbers produced is called the second difference, which for a quadratic sequence is always a constant value. And so for this quadratic sequence, the difference between each term increases each time by 3. And so this is what makes a quadratic sequence different to a linear sequence. In a linear sequence, it's the first difference between successive terms that's constant, but in a quadratic sequence, it's the second difference. So to find the next term in the original sequence, all we have to do is increase the number 11 in the first difference sequence by 3, and then add the result to 28, which is the last term in the original sequence. So we have 11 plus 3 is equal to 14, and so 28 plus 14 is equal to 42. So the next term in the sequence is 42. And then to find the next term, we add 3 to 14 in the first difference sequence, and then add the result to the last term in the original sequence. So we have 14 plus 3 is equal to 17, and then 42 plus 17 is equal to 59. So 59 is the next term in the sequence. And so for the quadratic sequence, 4, 9, 17 and 28, the next two terms are 42 and 59. And so that answers part A. For part B, we're asked to find the next two terms in the quadratic sequence -2, -5, -10 and -17. So as before, let's first work out the first difference. Well, the difference between -2 and -5 is -3, between -5 and -10 is -5, and between -10 and -17 is equal to -7. And so the second difference is equal to -2. Now if we add -2 to -7 in the first difference sequence, and then add the result to the last term in the original sequence, then we'll get the next term. So we have -7 minus 2 is equal to -9. And then -17 minus 9 is equal to -26. So the next term in the sequence is -26. Now let's repeat this process once more by adding -2 to -9 in the first difference sequence, and then adding the result to the last term in the original sequence. So we have -9 minus 2 is equal to -11, and then -26 minus 11 is equal to -37. So the next two terms in the sequence, -2, -5, -10 and -17 are -26 and -37. And so that answers part B. For question 2, part A, we're asked to work out the nth term expression for the quadratic sequence 5, 8, 15 and 26. Well, this time we haven't been asked to work out the next few terms in the sequence, but instead we've been asked to find an expression that will give the value of any term in the sequence. And to do this, we first need to know that a quadratic nth term expression has the form an squared plus bn plus c, where a, b and c are constants that we need to find. Now to find the constant a, we have to halve the second difference in the quadratic sequence. So let's first work out the first difference. Well, the difference between 5 and 8 is 3, between 8 and 15 is 7, and between 15 and 26 is equal to 11. And now let's work out the second difference. Well, the difference between 3 and 7 is 4, and between 7 and 11 is also equal to 4. So the constant a in the nth term expression is half of 4, which is equal to 2. So the nth term expression is now 2n squared plus bn plus c. Now, to find the remaining constants b and c, we first subtract the 2n squared term in the nth term expression from the original quadratic sequence. This is because we'll be left with the remaining part of the expression, bn plus c, which produces a linear sequence, and we can then work out its nth term expression. So let's create a table which shows the original quadratic sequence. Now include a row to show n, which represents the first, second, third, and fourth terms. Now we can include another row to show the 2n squared, which is the first part of the quadratic nth term expression we've just found. And so when n is equal to 1, 2n squared is equal to 2. When n is equal to 2, 2n squared is equal to 8. When n is equal to 3, 2n squared is equal to 18. And finally, when n is equal to 4, 2n squared is equal to 32. And so we can now create another row to show the difference between the original quadratic sequence and the 2n squared. So 5 minus 2 is equal to 3. 8 minus 8 is equal to 0, 15 minus 18 is equal to minus 3, and 26 minus 32 is equal to minus 6. Now these differences have created a new sequence represented by bn plus c in the quadratic nth term expression. And this new sequence is linear, and so we can now work out the nth term expression for this new linear sequence. Well, the difference between 3 and 0 is minus 3, between 0 and minus 3 is minus 3, and between minus 3 and minus 6 is also equal to minus 3. And so because the first difference is equal to minus 3, this means the nth term expression must include minus 3n. But when n is equal to 1, minus 3 multiplied by 1 is equal to minus 3, not 3. And so we need to add another 6. So the nth term expression is equal to minus 3n plus 6. Let's check this works by using n is equal to 3. We should get minus 3. So we have minus 3 multiplied by 3 plus 6, which is equal to minus 3. And so the nth term expression for this linear sequence is correct. And so putting this together with the 2n squared gives us the quadratic nth term expression, which is 2n squared minus 3n plus 6. Let's check this expression works by using n is equal to 4. We should get 26. So 2 multiplied by 4 squared minus 3 multiplied by 4 plus 6 is equal to 26. And so the quadratic nth term expression is correct. So the nth term expression for the sequence 5, 8, 15 and 26 is 2n squared minus 3n plus 6. And so that answers part A. For part B, we've got to do the same as we did in part A, but this time we have to find the nth term expression for the sequence of negative numbers minus 3, minus 7, minus 16 and minus 30. Well, as before, we know that the quadratic nth term expression has the form an squared plus bn plus c, where a, b and c are constants that we need to find. And to find the constant a, we halve the second difference in the quadratic sequence. So let's first work out the first difference. Well, the difference between minus 3 and minus 7 is minus 4, between minus 7 and minus 16 is minus 9, and between minus 16 and minus 30 is equal to minus 14. And then working out the second difference, the difference between minus 4 and minus 9 is minus 5, and between minus 9 and minus 14 is also equal to minus 5. So a in the nth term expression is half of minus 5, which is equal to minus 2.5. So the nth term quadratic expression is now minus 2.5n squared plus bn plus c. And as before, in order to find b and c, we first need to subtract the minus 2.5n squared term in the quadratic nth term expression from the original sequence. So let's create a table again showing the original sequence. Then we can add a row to show n, which represents the first, second, third, and fourth terms. Now we can add another row to work out the minus 2.5n squared, which is the first term of the quadratic nth term expression we've just found. And so when n is equal to 1, minus 2.5n squared is equal to minus 2.5. When n is equal to 2, minus 2.5n squared is equal to minus 10. When n is equal to 3, minus 2.5n squared is equal to minus 22.5. And finally, when n is equal to 4, minus 2.5n squared is equal to minus 40. And we can now create a further row to show the difference between the original quadratic sequence and minus 2.5n squared. So minus 3 minus 2.5 is equal to minus 0.5. Minus 7 minus 10 is equal to 3. Minus 16 minus 22.5 is equal to 6.5. And minus 30 minus 40 is equal to 10. And so we now have this new sequence, which is the sequence represented by bn plus c in the quadratic nth term expression, and so we can now work out its nth term expression. Well, the difference between minus 0.5 and 3 is 3.5, between 3 and 6.5 is 3.5, and between 6.5 and 10 is also equal to 3.5. And so because the first difference is equal to 3.5, this means the nth term expression for this linear sequence must include 3.5n. But when n is equal to 1, 3.5 multiplied by 1 is equal to 3.5, not minus 0.5. And so we need to subtract another 4. So the nth term expression is equal to 3.5n minus 4. Let's check this works by using n is equal to 3. We should get 6.5. So we have 3.5 multiplied by 3 minus 4, which is equal to 6.5. And so the nth term expression for this linear sequence is correct. And so putting this together with the minus 2.5n squared gives us the quadratic nth term expression, which is minus 2.5n squared plus 3.5n minus 4. Let's check this expression works in the original quadratic sequence by using n is equal to 4. We should get minus 30. So minus 2.5 multiplied by 4 squared plus 3.5 multiplied by 4 minus 4 is equal to minus 30. So the nth term expression is correct, and so that answers part B. If you found this video on quadratic sequences helpful, then please click the like button. And also consider subscribing to my channel where you'll find more GCSE maths videos. Thanks for watching.